Hello friends, today we can discuss this question from leetcode challenge. Problem name: search in rotated sorted array. So in this question you are given that suppose an sorted array in ascending order is rotated at some pivot unknown to you beforehand. As you can see in this example, this is a sorted array from 0 to 7 and this is rotated such that what we can do is, if you want to rotate it, what we can do is uh, rotate it in right direction. So if you move this in one right direction, this 7 will come ahead. Then again this 6 will come ahead. Then this 5 will come ahead. Then this 4 will come ahead. So as you can see, then the rotation, this the finality will look like this. So this is actually right shifted 4 times, this array. But after the shifting, what we can observe in this array is that this part is again ascending shifted, sorted, and this part is again ascending sorted. So at the pivot point, from the pivot point to the end, it is also sorted in ascending order, and before the pivot point, this is also sorted in ascending order. So in this question, you are given that you have to find whether the given value, target value, is found in this array or not. If it's not found in the array, you have to return -1, and if it's found, you have to return its index. And you may assume that no duplicates as like exist in the array, and the algorithm runtime complexity should be of O of log n. Okay. So in this question, as you can see, this part is sorted, this part is sorted, this is rotated, 4 right shifted, and you have to find out the target value of 0, so the index is 4. In this, we have to find out 3, it's the same array, but because 3 is not available, it's minus. So the logic is very simple. If we find out the pivot element, what we can do is, we can binary search the element in this half and in that half. That's the simple logic. So we just, our first logic is we have to find out the pivot element. Okay. So how we can find out the pivot element? Let's see in the logic. We can do a binary search on the whole array first, finding what's the pivot element. So let's do this example on this array only. This is here. Here is our low pointer. Here is our high pointer, and we come at the middle, at 7, and then we check whether 7 is greater than our high value. If it's greater than our high value, it means our uh, pivot element lies on the right. Why? Because if this value is greater and this value is smaller, it means this part of the array is the one which is rotated. This is the starting values of the array, and it is rotated such that because this part becomes smaller, if this part is greater, it means the array is left rotated, and it's this part is smaller, it means the array is right rotated, and the pivot elements lies on the right, and that's the main logic to find the pivot element. So let's see in the code. First we have to check whether the size of this array is not empty. If it's equal to 0, we have to return -1, and then we have to find the pivot element. This is our first objective. So we can make our high low pointers, low pointer equal to 0, and high pointer at equal to n-1. So n is the size of that. Okay. Now while low is less than high, what we can do is we have to first store the mid element, which is low plus high minus low divided by 2, and then if nums of mid is greater than nums of high, then low is equal to mid plus 1, else I is equal to mid. That's our logic to find the pivot element. Okay. Now after finding out the pivot element, we can do a binary search on like the both halves, or we can use a function, inbuilt function called lower bound. Lower bound give the first occurrence of the element in the range, the vector range you are want to find that element. So because we know the vector range is from this is the pivot element, so from 0 to that pivot element and plus 1 of that pivot element to the end. That's our ranges. So what we can do is we find out, so the lower bound function has one property is that if it founds our match, it returns the index of that element. If it doesn't find out that match, it gives the index of the element which is next greater than that element. So if you want to find out 6 in that, like let's assume there is an array and we want to find out 6 and it's 6 not present, so the next element greater than 6, the lower bound function return the index of that number. Okay, so we will use lower bound function and nums dot begin, nums dot end, plus, because we have to first add the pivot element, which is pivot element is at low -1, and we have to find out the target element. And because it return an iterator, we have to also subtract the first value, the first iterator value. Okay, lower bound of num dot begin plus low, comma, num dot end. Okay. Now, what we can do is we have to first find out if nums of a is equal to target, return it. Else if b is less than n, because let's assume in this array we search for 2 and we search for 3, and because 3 is not present, we search in this half and in this half. If while we searching in this half, because 3 is greater than 2, we the lower bound will return an index greater than that search number. Because there is no number greater than the search number, it will return the index out of bound greater than this array size. So if that happens, then we definitely know that our number is not present. So we have to ensure that b is less than n, and nums of b is equal to target. If those both of these conditions holds true, then yeah, we return our final index. Else we return minus. That's our logic to use lower bound. Yeah, function is returning perfectly fine, and it's returning. We are going out of bound. So what we are doing bad here is, let us check. Okay, this is correct. This is correct. And -1. We are searching for target element here. Num dot begin plus low plus low -1 target. Okay, mid plus 1 mid j. Okay, we can also, because if we search for 3, yeah, that's the same thing which is happening. If b is less than n, and you have to check now, because like whether b exists or not. So this thing, and check for this code. It's giving a runtime because 3. I think so. I think this is a. If a should also be greater than equal to 0, and that's this is only can give. Let's check. Just returning -1 to check whether what's our fault here. It's reaching. Okay, I think so. Our logic went bad in this part only. So what we can do is we find out num size low equal to 0, high is num n minus 1, and while low is equal to 0, uh, low plus high minus low whatever 2. If nums of mid is greater than nums of high, then low equal to mid plus 1, else high equal to mid. Yeah, so if we find out what the problem was I was writing nums begin n plus low. So it's not n, because we are finding the adding from begin to this value only. Yeah, now it's running perfectly fine. I have written out, because we are adding from begin to begin plus that pivot element. That's our array of starts, and this code is now accepted. I hope you understand the logic how to use lower bound. I like by mistake use end at this point. So that's what the code is saying. If you have any doubts still, please mention down in the comment box. I'll try to rectify it as soon as possible. And thank you for watching this video, and I'll see you.